Trig functions on any angle. In our study of right triangle trigonometry, we were only able to handle trig functions of acute angles, that is, angles less than 90 degrees. And we'd like to go further today so that we can handle angles which are greater than 90 degrees, also known as obtuse angles. We'll start out with an angle here in quadrant 1. Consider that this is drawn in standard position. Therefore, this here is our theta. And at the end of that line segment, I have the point x comma y. Well, if we drop a vertical line down to the x-axis, we will form a right angle here. This side would be x and this would be y because, look at the point xy. X is how far you go over, y is how far you go up. And I'd like to label that hypotenuse r, which might seem a funny thing to do, but it will make sense as you progress further in your study of trigonometry. Now we know by the Pythagorean theorem that r squared equals x squared plus y squared. If we take the square root on both sides, we'll have r equals the square root of x squared plus y squared. Algebraically, that does not equal x plus y, by the way. Now, looking back at our triangle and what we know from trigonometry using SOHCAHTOA, we would have the sine of theta would equal excuse me, the opposite y over the hypotenuse, so it would equal y over r. The cosine of theta would equal the adjacent, which is x over r, and the tangent of theta would equal the opposite y over the adjacent x. Now we're going to push a little further, and we're going to look at an angle which is obtuse, that is, which is greater than pi over 2. Pi over 2, of course, is equal to 90 degrees. Right, if we look at our illustration, notice that xy is in quadrant 2 here. Again, if we drop a vertical line down, we form a right angle. X and y become the sides of this right triangle. We have r here. Again, notice what theta is. See, theta is greater than 90 degrees because this here would be theta. Please notice that even though the x value would be negative and the y value would be positive since it's in quadrant 2, that the formulas from the previous slide could be used for r, for cosine, sine, and tangent. Okay, so we're going to use those, and let's do a concrete example, something I always like to do with anything I'm teaching. Here we have a point which is in quadrant 3. Both values are negative, negative 2 and negative 3. Let's work out the value of r. R will equal the square root of x squared plus y squared. So that will equal the square root of 4 plus 9, or the square root of 13. Of course, the actual values of x and y were given to us. Just look at the point. X is negative 2, y is negative 3. And now let's work out the values of all 6 trig functions. The sine of theta will equal y over r, negative 3 over the square root of 13. We could rationalize the denominator here by multiplying numerator and denominator by the square root of 13, and we will have negative 3 square root of 13 over 13. For the cosine of theta, we will have x over r, so that would be negative 2 over the square root of 13. I will rationalize the denominator. We will have negative 2 square root of 13 over 13. Finally, the formula for tangent of theta is just y over x. That will be -3 over -2, which will be 3/2. So we got the first three trig functions rather quickly. Let's find the reciprocals of those. The reciprocal of the sine function is the cosecant. It'll be easiest to work that out if you look at here the middle fraction and just do the reciprocal there. So the reciprocal of that would be minus square root of 13 over 3. It's easier to do the reciprocal of that than the final solution for sine, because notice it will be rationalized already. Now the reciprocal of the cosine is the secant. I'll do the reciprocal of this, and that will give me minus square root of 13 over 2. And then finally we would have the cotangent of theta would be the reciprocal of the tangent, and that would be 2/3. So there we are. We've got that. Let's do another example. At this point, 3, -4 is located in quadrant 4. We have that x equals 3. We're given that. We have that y equals -4. Let's find the value of r. It equals the square root of x squared plus y squared equals the square root of 9 plus 16 square root of 25, and so that equals just 5. So let's run through these 6 trig functions. First off, sine of theta. Sine of theta will equal the y value over r, -4/5. The cosine will equal the x value over r, which will be 3/5. And the tangent of theta will equal y over x, which will be -4/3. Let's run through the reciprocal trig functions. The reciprocal of the sine is the cosecant. So the reciprocal of -4/5 will be -5/4. The reciprocal of cosine equals the secant. Reciprocal of 3/5 will be 5/3. And finally, the reciprocal of the tangent is the cotangent, and that taking the reciprocal will be -3/4. So there we have all of those. Suppose we look at the point 0,2, which of course is located on the terminal side of the angle theta. Well, in that case, x equals 0, y equals 2, r will equal the square root of 0 squared plus 2 squared, which equals the square root of 4, so r is equal to 2. Alright, let's use these definitions. So the sine of our theta, this is our theta here, see? The sine of theta would be equal to y, which is 2, over r, which is 2, and that would be 1. The cosine of theta would equal x, which is 0, over r, which is 2, and that will equal 0. And the tangent of theta will equal y over x. And notice that will be undefined. There is no tangent for that angle theta. Running through our reciprocals, cosecant of theta would be the reciprocal of the sine. Well, that would still be 1. Secant will be the reciprocal of cosine. Look at when we had it in fraction form, 0 over 2. If we take the reciprocal, that would be 2 over 0, but that would be undefined. And finally, for cotangent, for cotangent of theta, if we do the reciprocal of 2 over 0, we will have 0 over 2, and that's legit. That will equal 0. So there we are. Using these definitions presented in this lecture, we can now handle trig functions on any angle. Good luck.